We have a problem. There exists 7,500 tons of junk in space, from old bits of rockets to tools dropped by astronauts in Leo orbit. We need to clear this up, fast.
First of all, we have to describe our mission. We'll aim to simulate debris collection in a Leo orbit as a nanosat docking to another dead nanosat. This will be done through a software simulation implemented in Python, in which physical conditions have been simplified into a 2D plane, in which there is translation movement in the X and Y axis and rotation movement. Also, it's important to acknowledge that the nanosat movement is triggered through a PD controller. Additionally, we have divided our mission in different phases, each with their own characteristic conditions. First, it is rough approach, where the majority of translation and rotation movement is undertaken, going from the initial position of the nanosat till the exclusion from the zone from the dead sat. Secondly is the final approach, where little translation movement is done and is intended to have zero rotation of the nanosat. And finally, there's the docking conditions, aiming to have an X and Y offset of 0.25 to the dead set and an angular offset of just 0.1 radians. Among our software solution highlights is an automatic location tracking, complying with mission conditions in all phases, docking the nanosat and deadsat through the intended phase, preventing the satellite bases to touch in the simulation, as well as successfully undertaking all challenges.
Now you're going to see a demonstration of the three challenges. The first one is a linear translation, the second one is only a rotation, and the third one is a mix between both with a linear translation and a rotation.
We've also intended to implement further applications to our solution as a diversion maneuver, studying the case in which both satellites are closely aligned in the same axis and intended docking phases are opposite to each other. Here there's a problem that the simulation will make both satellites to collision, and our solution is to undertake a diversion maneuver and displacement to the new position to safely undertake the maneuver.
Finally, the dead satellite was in any random position, and also the X and Y components of the velocity were random. For this, the main problem was the dependence on the distance, and we had to find a solution to counter-react this dependence and also to adapt the velocity in the docking phase. And further development that could be used is the adaptation also to the angular velocity of the dead satellite.